Good afternoon. Today we'll be testing the DV routing lab. As you can see, I've taken the liberty of drawing what I believe this um, network connection, in a really basic sense of the lab, would essentially look like in the event that it were a true network. As you can see, we have routers 0, 1, 2, and 3. Routers 1 and 3 are not directly connected. However, 0 and 2 are connected to all routers, and 1 is connected to both 0 and 2, and 3 is connected to both 0 and 2 as well, at a distance, or at a cost of 1 from 0 to 1, and an initial cost of 1 from 0 to 1, 1 from 1 to 2, 3 from 0 to 2, 7 from 0 to 3, and I believe 2 from 2 to 3. So if we go ahead and share the desktop, we can go ahead and look at what is actually in our lab here. So we'll start out with db.cpp. It actually says for us not to touch it at all. So we're just going to go over it pretty quickly. Essentially, it's just telling all of the different routers to share their information in terms of what they currently have for their routing tables. So we'll go ahead. We're going to focus on the nodes, really, because that's what's kind of important. Now, on my blog, I posted node 0 only, and the reason for that is because they're all relatively similar. But we point out some, we'll point out the differences between the two. We sometimes really see offbeats, but it's also already listed out. And they're in order of the most compliance. So because, for example, this is node 0, and so we have a test 0, so we can send it to 1, so node 0 to send to node 2, 2 to node 0 to send to node 2, 7 to node 0 to send to node 3 originally. Now that'll update as we go because of the way that this program is going to work. It's going to try to find the best routing algorithm possible. Now one of the other things that's going to change actually which is down here, the source ID, which is going to be 0. That's going to change that info because it's what determines which routing it is. So for example, currently we're 0, so everyone will be able to do it. Now if you go down here, you'll see that if in the event that a router once it receives information, the other router realizes that it's not sending in the most efficient manner possible, it's actually going to update, change its cost to then it's going to go ahead and send that back out. If it gets changed, it's going to tell all the other routers that this is its current new cost because it might change how the other routers are sending as well. So now if we go into node 1, we'll just show the other changes. Again, you have an update from the source ID. And then you'll see on this one, for example, it's going to cost 1 to go to router 0, 0 to go to itself, 1 to go to 2, and in the event, such as router 1, as you saw from the earlier image, that the routers are not connected originally and they don't know how long it would take to get to each other, it has an infinity count, or an infinite count, which in this case is 9,999. The cost is just so high that at the current time it would never try to send directly to 3. It would understand that its fastest way is definitely going to be through either through router 0 or router 2. Again, we'll go and show the same thing in router 2. You have a different current routing table, and again in router 3, and you'll see in router 3, much like in router 1, because they're not currently connected and don't know about each other, you have an infinite number in order to ensure that router 3 doesn't try to send directly to router 2. So now we're going to go ahead and start the program and show off the numbers that we get a little bit. taken the liberty of figuring out what the final table should be, which so if we come back out, we'll see that the final numbers should be in the realm of somewhere along those lines. For 0 to get to 0, 1, 2, and 3, 1 to get to 1, 2, and 3, 2 to get to all 4 routers, and 3 to get to all 4 routers. So it should, for example, where it currently takes 9,999 cost to get to 3. In the end, it should only cost it about a total of 3. And for 3 to get to 1, it should only cost a total of 3 as well. Where currently they're both at an infinite number. Luckily, Dr. Rosie chose not to make this assignment too difficult in the fact that we don't have to worry about the changing of a cost between, say, router 1 and router 2, which would then update the entire table again after we got our final values. So we're just going to set a trace of 3. The router, or one of the sources, in this case it's going to start with node 0, is just going to send out to all the nodes it's connected to its current routing. So then, after they all receive that, router 1, or node 1, I'm sorry, is going to go ahead and say, oh, so router 0, and out to both 0 and 2, the only 2 nodes it's connected to, that its current numbers are 1, 0, 1, and 9999. So then source 2 is going to say the same thing out to 0, 1, 2, and 3 because it's connected to all of them. And source 3 is going to send out to 0 and 2 because those are the only 2 it's connected to. So now after that all happens, node 1 is going to update. Node 1 is going to say, oh, okay, I can get to... it's going to take the information that it got from node 0, and it's going to say, oh, okay, I can get to node 3. Wait a second, never mind, now I have all this information from 2, and 2 can get to router or node 3 in just a cost of 2. I can get to router or node 2 in a cost of 1. Or node 3. And it's going to send that out to both 0 and 2. And so then once it sends out that information to router, after it sends out that its original information, 0 is going to update, and it's going to say, okay, you know, router 1, you didn't really give me anything on 3, so I'm going to stay at 7 there. However, I'm going to go ahead and take the fact that you can get to 2 faster than I can. So I'm going to update and get to 2 and just a cost of 3. It will cost 3 as updated. And so it's going to send that out to 1, 2, and 3. And then, so after it sends that out, source 3 is going to update its routing tables and realize it can get to number 1, or router 1, at the more efficient cost of 7 than 99, or sorry, rather 1 it cost 8 rather than the 9999 it was currently operating on. So it's going to send that out to 0 and 2 and let them know just in case they need to operate through 3 and that's faster. Then, I'm sorry if this is getting long and following along. So then source 0 is going to receive is going to take the information that it receives from 2. Okay. Okay, now I can get to source 3, or node 3, and it costs 4 rather than it costs 7. So this can go down to, we can go from 0 to 1, it costs 1, 1 to 2, it costs 1, 2 to 3, it costs 2, for a total overall cost of 4. And now, source 0 has its best possible routing table. That's just 0 to 1 to 1 in node 1, 2 to node 2, and 4 to node 3, and that's the best that you can do. So that is now perfectly set. So now all the other routers are going to keep updating, and they're keep letting each other know, okay, you got a better path than I do, so I'm going to take this. This is my current configuration. So what do you have? And then they're just going to go back and forth until eventually all of them get their best network configuration. Which, for example, 3 has now figured out that its best network configuration is going to be 4 to router 1 or node 0, 3 to node 1, 2 to node 2, and 0 to itself. 2 is eventually going to figure out that its best configuration is here, which is send out to node 0, as you can see, 2, 1, 0, 2, and finally 1 is going to figure out that its best configuration is, for example, right here, it's send out to destination 2 to ensure that 2 goes, which is 1, 0, 1, 3. Now, if in any case any of the network lines for some reason were cut or terminated or changed, now this whole table might update again, but for the time being, all of the network nodes are functioning at the top level in order to communicate with each other. The top cost of which just being only 4 from 3 to 1 or 1 to 3, or 0 to 3. 3 to 0 or 0 to 3. I'm sorry about that. So this is just an example of how the DB routing table works. It's just it's really just a ability by the network to work together in order to say, okay, you know what, I think I can operate better than at a 7 or at a 9999. And let me know what you got. And then once it receives that information, it automatically updates. And sometimes those updates even help the fellow node that it just received information from in the big scheme of things. So we eventually will get our proper routing table, and then after that, everything should be able to route in a successful manner.